All right, greetings. Uh, Thank you, everyone. For this presentation, we will be giving a status update on the Canadian retail food price analysis conducted by the WeBe Data Sciences, for March 19th, 2024. So, for today's agenda, what we have is just the general project summary, our profile, and a timeline chart. I'm pretty much going to skip by 1 and 2 relatively quick as they were present on all of our recent updates. And then what I'm looking to do is a deep dive into the project progress update along with the predictive models and any data updates that are going to be presented. So project summary, essentially at the end of the day, what we're looking to do is provide the Bank of Canada with a recommendation on interest rate hikes, either increases or decreases based off of our findings with CPI and retail food prices. Profile, my name is Grant Friend. As you can see on the left-hand side, I'm the team lead. In the middle, we have Shirag, and on the far right, we have Sarath as the programmer. So where are we on the timeline? So as we are approaching the end of March, you can see that we're nearly closing out our testing phase. Then we will get into the release phase of the project. So our testing phase, we're hoping to finalize our predictive models, both for CPI and the retail food prices, and then also start to transition to the data presentation and business intelligence stage. So project progress update. So from the last time we did this update, we had completed our automated data pull, both CPI and retail food prices, the data cleansing, so the EDA, exploratory data analysis, aggregation of data for retail food prices, and the data dictionary. What has been new since our last update in late February? We've been testing the predictive models within Google Colab. We've also been looking to develop the Power BI template for our data repository. So the current task, what are we doing right now? We are formalizing the predictive models and determining the true champions. And so it looks like the random forest appears to be the optimal model. However, recent tests has maybe concluded that it may not be the case. Change requests, threats, and challenges. Continuation model prediction expressed across a longer timeline. So we're looking to see fluctuations within our prediction for future CPI data and also future retail food prices. Currently, unfortunately, we're not really seeing that. So some deeper dive in that is needed. The joining of CPI and retail data food prices is required. And then activities to be completed by next week. We're looking to do, as mentioned, the Power BI dashboard development. So this is where we stand right now, the predictive retail food prices, the predictive model development. So for all intents and purposes, all we're seeing here is just a couple screenshots. I believe this one has the gradient booster as our champion regression with a statistic that's kind of blurry. So what we're going to do is I'm actually going to, for the sake of time, I've actually ran the overwhelming majority of our logic, and we'll then pick it up at the spot after we do some EDA analysis. So as you said, this is the final stop of our EDA analysis on the CPI. So now we're going to continue here. And so from here, we're going to be importing some pandas, some sklearn, both the model selection, the pre-processing linear metrics, so on and so forth. So the metrics that we're using is the R squared and the mean squared error. So as you can see, I ran it earlier. However, what we're going to do is run it once more. So as you can see, the logic actually works, and it works based off of our food price data, so data frame number 4, which is completed earlier in the logic. So based off of the output, we ran the linear regression, random forest, gradient boosting, the decision tree. So the gradient boosting, the reason why I would conclude that that would be the more optimum model, simply because of the R squared error is slightly better, so the closer to 0 than that of our random forest. So to me, I would conclude that that would be our most optimal model. So that's the one we're going to use going forward. So in the next portion of this, what we're seeing is the actual download of the model itself. So you see, I've tested it out a few times already. And then we start to do, we try to actually forecast. We're trying to forecast and visualize how that model would perform over time. So this is kind of like the visualization of both the test and training data. As you can see in the visuals below, the majority of our data kind of lies within here. We do have some outliers, but the testing data and the train data seem to be relatively close. Okay, and as mentioned earlier in a bit of the challenges, so what we're trying to do here is actually predict the fluctuations of our food prices, but you can see that the prediction is flat. And so to me, and we're trying to predict all the way to 2026, to me that indicates that perhaps there's an overfit in the model. Perhaps there's not as much fluctuations within the data as like the data set that we're utilizing exists over several years. There's several different categories. The values at which we're trying to predict as a key value indicator is actually relatively strong. So this is a cause for concern. I don't think it has an impact to the model itself. It's more so just trying to get a better understanding as to why we're not seeing the fluctuations that we would probably expect to see. Regardless, we start to break it down a little bit further, right? So from there, this is, as a whole expressed over just all of Canada, extending it out for an additional 2 years. So from here, taking the same information, and then we're running it broken down by product categories. So the interesting thing that we're seeing here, predicted mean food prices, is over time, like you're seeing these are the fluctuations we expect to see. However, I don't think the graph does a good job of that visual representation of what we would like to see of the fluctuations. Broken down by the subgroups. Okay, there's something present. However, I'm not sure if it really has the best bang for value of what we're trying to do. So you see this, unfortunately, that needs to be an edit. That should express Canada. That's what's presented up here. So, and then here we are, we try to do an additional breakout by the just targeting fruits to maybe see if we can see some nuances, as you can see here, just in the fruits category. And then from there, we start to see, okay, maybe there's fluctuations based off each individual product. So this might take a little bit to run. And then the output, so this is where I find this to be rather interesting. So here we have for canned food sitting at roughly, call this 2.17. Here you have it higher for dairy, let's call it 4.55. Here's 3.4 for frozen. So you do see that, everything remains flat, unfortunately, but based off the individual product categories, you can kind of see what's already higher based off of the data that we've already obtained, right? But as again, I've mentioned it several times, we would expect to see some sort of fluctuation. So we'd like to see that. And potentially we can see that when we start to actually do our BI visualization using the gradient boosting or any type of model that reflects that. So this is the most recent update that we have in regards to model development. The next stage is to try to look at it from the CPI data. So that's yet to be seen as of right now. Regardless, forward progress is being made, which is fantastic. The biggest challenge we're seeing right now is just the lack of fluctuations within the models. And with that,
Thank you, Grant. Hi, I'm Sarath. I'm the developer of this team. I'm going to walk you through about the data manipulation and data cleansing activity we did for this project. So this is all the code is already executed. I'm just going to explain how it is done. So this is the import statement we have for this project. We are actually importing a library called StatScan. This is a library to pull the data from StatScan website automatically. That import is done here. And then we are initiating the StatScan library and downloading the retail food price table from StatScan website. This is the product ID for that. And after that, we are collecting only the required columns from the collected data frame. Then we are applying a manipulation logic to split the product and unit out of the products column as two separate columns. And then we are applying the logic to rename the newly created column. then removing the duplicate column out of that. And then we are checking for anomaly of data from the newly created column. We found an anomaly on the data set, that is a data which contains a value called T20 backs. So we have a logic to handle that anomaly. So after handling that, we are analyzing the data further, and then we are checking the values producing any null value or not. So by doing this, we are able to check whether the value is producing any null value or not. And then we are removing the unidentified non-food products. So this is another anomaly. There are some other products which present in the table like toothpaste, shampoo. These are in the food price analysis table. So we are removing those also. After that, we are doing one more analysis to calculate the volume and measure out of the unit column. So that's the logic handled here. After that, we are applying a normalization on the converted unit column because sometimes each rows will have a different set of units like liter, milliliter, like that. So we are unifying all the units into a single view. So after doing that, we got the perfect units. As you can, this is the original unit present in the table. After applying the manipulation logic, this is our final unified units. Then after that, we are applied some uh, logic to categorize the food product into different categories like oil, butter, margarine will comes under oil. Like that, we have different categories for each food product. So this is what the manipulation we did on the uh, retail food price data. After that, we did some few ADAs on top of that, like getting the average food price over the time. So this is one EDA for that. And let me go through another thing. Let's see where next will be getting the CPI data. So CPI, the customer price index table, is need to be incorporated in this analysis to do the prediction model. So we have successfully pulled the CPI data from the StatsCan website. This is the product ID for CPI data. And then we did applied some filters on top of it, and we applied the filter to look at the data from 2006 onwards. So this is how the data manipulation logic work. After that, we also worked on finding the NAPCS code for each food product. This is actually will make the work easier to join the data sets because it will be a many to many join. By incorporating NAPCS code, it will be easy to categorize the food products easily while preparing dashboard and as well as doing SQL joins. That's the main reason for that. NAPCS is nothing but North American Product Classification System code, which is available in the StatsCan website itself. So we have manually collected each product and categorized everything and put it as a list. Hereafter, we have to prepare a dashboard based on this data set that we got. Thank you.
Much, Sarath and Grant, for your presentation. Now I'll quickly go over the Power BI dashboard we have created so far. So if I talk about the first report, then it is the CPA trend. So we have data from 2006 to 2023 for the CPA. If we check CPI in the year of 2006, then the sum of all the values which we had was around 539,000. With the time, it increased, and by the year of 2023, it's almost like 10 to 15 times of what it was in the year of 2006. Uh, if I talk about the next line chart, which is about food price trend from the year 2017 to 2023, it is clear from the chart that the price of the food is increasing with time. Each year, the price is increasing gradually, and by the 2023 year, it's almost I would say 1.5 times of increase in the food price than the year of 2017. Then the last visual I have created is about sum of food price by product category. So if we check, we have different product categories: meat, vegetables, fruits, oils, and other products, dairy products as well. So the highest chunk is from the meat category. Likewise, the lowest chunk is from juice category. So we have created this visual so far. By the next week, I'm anticipating to complete all the other visuals. Thank you.